Okay, so today we're going to talk about relations and functions. This is a huge topic in algebra, and going forward, it's a huge topic in Algebra 2, it's a huge topic in calculus and pre-cal, and this is something that I really want you guys to understand. Now, note this, relations are general things, and then functions are specific types of relations. So I want you to think of functions as like a subcategory. If this was like one, then functions would be a subpoint, okay? So a relation, let's talk about what that is. Anytime you can write ordered pairs, that means there's a relationship between the x and y, and you have a relation. So again, super general, there's not really any rules other than the fact that you have to be able to write ordered pairs from your data. Okay, so let's do a practical example here. Here we've got a Texas relay. So if you get first place, you get 10 points. If you get second place, you get 8. Third place, you get 6. Fourth place, you get 4. The scoring system can be represented as a relation, and here are the ordered pairs. Now, there's a lot of different ways that you can represent relations, and I want you guys to understand how to do those. So let's talk about be written as ordered pairs. A lot of times they'll be written in a table, though. A lot of times they'll be written as a graph. And other times they're going to be written in something called a mapping diagram. That may be the only one that's new for you. I'm going to write an X and a Y on top of my mapping diagram, and then we'll talk about why I did that in a minute, okay? If you want to express your data in a table, then just look at how your columns are labeled. Pretty much it's usually going to be X in the first column and Y in the second. Here it's place, which is our X, those are our X points. It's first place, second place, third place, and fourth. And the points that go with those. So for first place it's 10, for second place it's 8, third place it's 6, and fourth place it's 4. So that's a table, and that's how you would represent. If you were doing a graph, notice I didn't put any labels on here, so it's important for you to figure out how to label your axes. We're going to do place on the x-axis and points on the y. We'll talk about how you know which goes where later in the year. Now, we don't want to have all of our data bunched up in one place, so it wouldn't make any sense for me to label that a 10 because our data doesn't even go to 10. So let's instead label it like this. Let's put a 1, a 2, a 3, and a 4. The more you can zoom in on your data, the better. And on this point side, I'm just going to count by 2s. Okay, so now let's graph our data. It said for first place you get 10 points, so that would be that point right there. Second place you get 8 points. Third place you get 6 points. And fourth place you get 4 points. So that's the exact same data represented in just a different way, which is our mapping diagram. This may be new. I don't have room to write it up here, but always know your first oval is your X, and your second oval is your Y. And then we're just going to list our points. So 1, 2, 3, and 4, those are our X points. And 10, 8, 6, and 4 are our Y points. The other thing that you need to do with a mapping diagram is basically tell which X's go with which Y's by using arrows. So since 1 and 10 go together, we're going to connect them with an arrow, and so on. So if you see a mapping diagram like this, you can take only this data and know, for example, one of your ordered pairs will be the 0.44. And then you can graph it if you want to, or you can put it in a table. Okay, another really super important topic is when we talk about the domain and the range. So your first blank there is domain. And domain is the set of all x coordinates. The other one is the range. And that's the set of all the y coordinates or y values. So on our track application, all the x values were our domain, and all the y values were our range. My dumb way of remembering this is to remember the saying domain x, and rangey. So if you'll notice, domain and x go together, range and y goes together. Okay, so again, domain is basically a list of all of the x points that would be included in this graph. Because this is a continuous graph, we're going to have an infinite number of points in there. So we're going to have to write our domain not as separate points, but actually as an inequality. Now, I think the easiest way to figure out what your inequality will be is by imagining that you have this graphed on your calculator. What if I asked you to zoom in, or in other words, to change your window so that this is all that you see? What you need to think about is what is your x-min, what is your x-max, what is your y-min, and what is your y-max? Well, let's talk about it. The domain is going to be our x's. We're going to write it like this. We're going to have an inequality. I'm not finished with it yet, so just give me a second and then you'll see exactly how it looks. For domain, it's our x's, so we need to think about what's the lowest x that you saw? Well, it's right here at 1. So we're going to go from 1, and the biggest x that you're going to see is at 3. And now let's continue our inequality. 1 is less than or equal to, equal because our dot is filled in. So 1 is less than or equal to x, which is less than or equal to, again the dot is filled in, so x is less than or equal to 3. Now let's talk about our range. You can tell range by thinking about what you would enter as your y-min and y-max. Our y-min is right there at 2, and our y-max is up here at 4. So our range, I'm going to write it down at the bottom so I have room. Range is going to be y. Remember, we're not talking about x anymore. We're going to go from 2 to 4, and then it's 2 is less than or equal to y, which is less than or equal to 4. Those are, I think, the hardest ones for students to get. I think your best support is drawing your box around it and thinking about what's the smallest and the largest x part of that box, and what's the smallest and largest y part of that. Okay, and then here's our mapping diagram. These are easier because you already know that that first bubble or oval are your x's, and the second one, those are your y's. So dominex and rangey are domain. Now this time we have specific points. There's not a continuous graph. These are separate points, so we can just list them off. The domain is 6, 5, 2, and 1. And then the range, our y values, are going to be a -4, a -1, and a 0. Now notice, there's actually 2 points that have 0 for y, but we don't need to repeat them when we do the range. So only list each number in the range and the domain, only list those once. Okay, and now let's look at our table. Again, the tables are pretty easy for finding domain and range. Domain, remember dominex, all of our x values. Again, they're listed off, so we don't have to do an inequality, we can just list them. And the range are all of our y values. Oops, not that. It's about to do an inequality. Notice we have 1 repeated twice, but we don't need to write it twice, just write it once. And then you've got your range. Okay, and so then the last one is, if you'll see at the top, it says a blank is a special type of relation that pairs each domain, so every x with one y. So does that sound familiar, like a Cyberchase episode that we watched with a frog? Remember, every input had exactly one output, where you could always be certain about how many times the frog was going to jump based on which button you pushed. This is, hopefully you know it already, is a function. Notice here it says a function is a special type of relation. Just like I said before, functions and relations aren't two separate things. Functions are just specific types of relations. Okay, so remember my dumb saying where I said, and if you don't remember, look at the pink poster on the back wall that has the hearts on it. That's what's going to help you remember. It says for a relationship to be functional, there must be no repeating x's. So anytime that you look at a data table, you need to look to see if the x's repeat. If the x's don't repeat, then it's a function. So we could say a is a function. Remember, can the y's repeat? No problem. Y's can repeat. It's just like the frog. If you pushed button number 1 and he jumped 3 times, and pushed button number 2 and he jumped 3 times, you would still be able to control him. So the only thing that can't repeat are the x's. All right, so then on B, mapping diagrams are a little harder to see whether the x's repeat. So what I would suggest doing is using your mapping diagram to list ordered pairs. So let's look at 7. 7 is an x value that goes with -1, but it has 2 arrows. So there's also another ordered pair that is 7, 0. At that point, we already see repeating x's, and because of that, we have to say that it is not a function, or not functional. Okay, and then the last one. This one's a little bit different because it's graphed. If it's graphed, there's a different way that I think is easiest to figure out whether it's a function or not. It's called using the vertical line test. So let's write that, vertical line test. If something is a function, you will not be able to cross the graph in more than one place by drawing a vertical line. So let's look at this. If I drew a vertical line on this graph, notice my green line crosses the red graph 2 places. What that means is that we have repeating x's. We've got one that says, like, if you have a -1, just look at this. This point right here would be maybe a -1, positive, let's say 2, 4, like 3.8. And then this point right here would be a -1 and maybe a -3.8. All right? Yeah. Do you see repeating x's? Yes, you do. So it's harder to tell it from the graph, so I think the easiest way is to draw yourself a vertical line. If it ever touches the graph in more than one place, you know it is not functional. So we would have to say that this is also not a function. And that's it for domain and range and functions and relations. You guys have a good day, and I will see you soon.
Made with Doodlecast Pro.